Hi everybody, quick video here for lesson 8.1 as we embark on chapter 8 together. This will be the last chapter we do this year in Algebra. So shout out to all you Algebra guys watching these videos. Thanks for doing that. I want to walk you through just one of the problems today. It's a pretty easy lesson. I think the book is pretty self-explanatory and the accompanying PowerPoints that I posted for you are pretty self-explanatory. But I anticipate there might be some questions about number 4. And I'm not sure how good a job the book does explaining it, so I'll do what I can here. Anyway, chapter 8, as you can see, is going to be all about quadratic everything. Quadratic equations, quadratic functions, graphing quadratic functions, solving quadratic equations, and lots of different ways to solve quadratic equations, okay? So that's the theme of chapter 8, quadratic, quadratic, quadratic. Quadratic means, as you should know by now, that we have degree 2, okay? This is your standard form of a quadratic function or equation. I've written it as y equals ax squared. It's the squared on x that makes it quadratic, ax squared plus bx plus c, right? So you can tell something's quadratic if your degree is 2. Pretty easy, okay? A little later on, we'll be writing this as f of x equals ax squared plus bx plus c. We'll be solving equations in the form ax squared plus bx plus c equals 0. Okay, any quadratic is going to mean something squared. Okay, and as you also know too, how does a quadratic function graph? Graphs is a parabola, okay, like a kind of a bowl or dish shape, okay, curve that can either open upward or downward, okay? In this particular problem, the book wants us to look at, is there a way to just looking at a table of data, some x, y coordinate points, to determine if that's quadratic just by looking at the data set, okay? You could graph these points out and look at it and get a visual sense of it that way, but the book is trying to show you here that there's a mathematical way to show that that's quadratic without actually plotting the points. And I'm going to show you what that's all about right now, okay? Recall that when we looked at lines earlier in the year, we looked at the differences in x, the change in x, and the change in y. And if the ratio of those changes remained constant, then we had a line, okay? We had a linear function, okay? Let's analyze those. I'm going to use my green pen, okay, to look at those differences, okay? Going from x to x to x to x here, we have -4 to -3, -3 to -2, and so on. Those are all constant, +1, +1, +1, +1, right? Okay, that's going to be given in these problems, okay? The change in x will be constant. Now we look at the first differences in y, okay? Here's what you have to start tracking here. Going from 39 to 18, that is a difference of -21, right? We're subtracting 21, okay? Going from 18 to 3, what are we doing? That's a difference of 15. We're -15, right? Okay. Going from 3 to -6, what are we doing? That's -9, right? And going from -6 to -9, what's that gap? That's -3, right? Okay. So look at those numbers. Now, if those had been the same, okay, then it would have been a line. If those had been constant and the ratio of those to the x had been constant, then it would be a line. Clearly this is not a line, okay? But the question is it a quadratic function, okay? And to answer that, we have to look at what are called the second differences, okay? These numbers that I just did right here in green, those are called the first differences, okay? Those are called the first differences. We need to analyze what are called the second differences. So I'm gonna switch pens, okay? Let's go red, okay? Going from -21 to -15, what's that gap, that difference? That is +6, right? We're adding 6 to get there. Going from -15 to -9, what are we doing? Again, +6, aha. Okay, -9 to -3, +6, aha. Those are called the second differences, okay? Those are called the second differences, and because those are constant, because the second differences are constant, and it's no coincidence, by the way, that it's we have a quadratic function, degree 2. We're looking at second differences, okay? For a cubic function, degree 3, you'd be looking at third differences, and so on, okay? Because the second differences are constant, the answer to this question is yes, it's a quadratic function, okay? Hope that helps. Take care, all. Bye.